Modular engines. Love them or hate them, this is how you make them. There are 3 sizes of modular engine: 1x, 3x and 5x. In each size there's a crankshaft, cylinder, engine drive belt, clutch, gearbox and flywheel. There are also common parts that are used with any size of modular engine. The main common parts are air manifold, fuel manifold, exhaust manifold, cooling manifold, temperature sensor and the manifold pipes. The engine drive belt parts are alternator, engine starter and fluid pump. First I'll go over the intended modular engine layout, and then I'll cover some tricks and alternative building methods. To begin building a modular engine, open the parts menu and type mod. This will filter basically all the components you need minus the fluid ports. I'll build a 1x modular engine for this tutorial, but the method is more or less the same for any size. Start by placing crankshaft blocks as long as you want your engine to be, making sure that the crankshaft part is connected at the side with a circular texture. Place cylinders along the top of the crankshaft so that the flat grey side is facing away from the crankshaft. This is the default placement orientation. At one end of your crankshaft, place an engine drive belt. The side ports of the engine drive belt are where you connect the alternator, fluid pump and starter motor. On the top side of the engine belt drive, place an alternator. You'll see that before placing any of the belt drive parts, a belt pulley can be seen. Line this up so the belt goes around both pulleys for the correct orientation. Place an engine starter on one side of the engine drive belt and a fluid pump on the opposite side of the engine drive belt. Pressing U will flip the fluid pump, letting you change the direction of the fluid out port. Add an air manifold to the side of the first cylinder. It can be facing any direction as long as the 4 manifold holes are connected to the cylinder's manifold holes. I would like to place this one facing forward so there's space for a fluid port. Add a fuel manifold to the second cylinder. There are 2 different types of exhaust manifold, a straight pipe and a 90-degree corner pipe. Place an exhaust manifold onto the third cylinder. Adding a flywheel is optional. It is placed between the crankshaft and the clutch. I'm going to add the 1x flywheel at the end of the crankshaft. Flywheels are larger than the crankshaft on all sizes of modular engines, so even though this looks much too large, it is the correct flywheel for this engine size. Now add a clutch onto the flywheel. If you're not using a flywheel, the clutch attaches to the circle texture of the crankshaft. In your parts menu, search for air and select the air filter. This part does not filter air. It is only an air filter visually. Connect this to your air manifold. It works the same way as any other normal fluid port. Go back into the parts menu and select the air ram. This is the fluid port I like to use as exhaust, so place this on your exhaust manifold. Now attach a small fuel tank directly to the fuel manifold. Pipes can be placed between these fluid ports and the manifolds if you want to route the intakes and exhaust to some other location in your build. Technically this engine will run. While it has no cooling loop, it will start and run. But it will also heat up very quickly and explode. This is important to understand. Engine cooling will not determine if your engine will start or not, only if your engine will continue to run over a long time. To add cooling, search your parts menu for rad. I'm going to use the 3x radiator without a fan. For this example, I'll place the radiator on the bottom where I can directly attach it to the fluid pump. Then attach a cooling manifold to the free fluid port on the fluid pump with its manifold ports facing up. Add a corner engine manifold to connect the cylinders to the cooling manifold, and then a normal 90-degree pipe to connect the cooling manifold back into the radiator. When this engine spawns, the radiator pipe, cooling manifold and cooling pump will all be filled with water. No extra tanks are needed. I highly recommend you use an engine controller from the workshop, but we can do some constant numbers and buttons to showcase the logic. The basic logic to make a modular engine run is that you use 1 part air and 0.5 parts fuel. Add a constant number with a value of 1 and a constant number with a value of 0.5. Connect the constant 1 to the air manifold and the constant 0.5 to the fuel manifold. While we're connecting these numbers, you may have noticed the fluid pump and alternator also have a number input. So if you leave them disconnected, the alternator will not charge your battery and the coolant pump will not move coolant through the loop. So connect the constant 1 to the alternator and the fluid pump. Add a push button and connect it to the engine starter. Add a battery and connect the electricity to all the components. Let's spawn this little engine in and give it a test. Hold the push button down until the engine starts. A modular engine will continue to run without a starter motor after it passes 2 RPS. A flywheel will add load to the crankshaft, causing the engine to take longer to start. With no engine controller, the engine RPS will rise up to its maximum of 60 RPS and stay there until it explodes or runs out of fuel. As you can see and hear, a modular engine with no controller is not very pleasant. Let's go back into the vehicle editor and use an ECU from the workshop. I'm going to use the ZE modular engine controller. Generally ZE controllers will work first try. Let's just leave the constant numbers from before because we still need a way to engage the coolant pump and the alternator. Place the engine controller and a lever which will be used as throttle control. We need to replace the push button with the toggle button because of the way this ECU detects its on signal. Connect all the nodes from the engine controller to their corresponding parts and make sure to change into composite view to connect the cylinder node. Modular engines output their temperature via the composite node, so most builders pick up the temperature via composite rather than the modular engine's temperature sensor, as it saves us some space. The toggle button could be replaced with a key and the lever's output replaced with W and S on a seat. So there you go, a working modular engine. This controller doesn't come with any kind of clutch control, but there are some other ZE controllers that have everything packaged into one microcontroller. And here are some other modular engine controllers I would recommend. LC Advanced Modular Engine ECU, Toasterys Modular Engine ECU, MTech All-in-One Modular Engine ECU, C4V ECU V3, and of course, ZE Modular Engine Controller. Now we can have a look at some alternative building methods. 1X23 cylinder. It has 6 crankshafts with cylinders on all sides. There is a single catalytic converter between the exhaust manifold and the fluid port to reduce the exhaust particles. The more catalytic converters you use, the less exhaust particles are produced and the more your engine's performance is negatively impacted. I have 2 alternators on this engine to provide more generated electricity. There is no flywheel as they are usually unnecessary. When placing cylinders on multiple sides of a crankshaft, the manifold ports need to be connected for all cylinders to share fluids. Cylinders beside cylinders share fluids, and manifold pipes can be used to connect cylinders on other sides of the crankshaft. 1X 17 cylinder supercharged. To supercharge your engine, either add a pump between the air intake and the air manifold, or use an air scoop as your air intake to force air into your manifold when you get up to speed. Mitchell engine low. This is a 4-cylinder 3X engine to be used in boats. When I strip away all of the detail work, you can see these cylinders are rotated so they connect on their manifold ports. This is somewhat unusual but allows the sides of the engine to be decorated because the ports come out from the front and back. Then a line of manifolds run below the engine where it can be hidden and all the air, fuel and cooling manifolds are connected out of the way. On a larger engine, multiple cooling manifolds may be required, and the use of electric pumps allows for a higher flow rate. This engine is cooled directly with seawater. A trick I'm exploiting is the exhaust manifolds are connected into air manifolds. Air manifolds delete exhaust and other fluids. Another feature of this engine is that I'm using an electric motor, clutches and a generator to start the engine and recharge the batteries. The electric motor spins the engine up to 2 RPS, which starts the engine, then the motor disengages and stops while the generator engages and charges the batteries. You might also notice the air filter is on the same pipe as my starter system. Power and fluid can move through the same pipe. All the techniques I have used are to save space and allow for more interesting design of engines. And that's pretty much it. Thanks for watching, leave us a like, and I'll see you later.